Ever since I was a little kid, I've always loved building things, whether it was with Legos or building blocks or these weird construction sets my grandma had at her house. If I could make something whole out of separate parts, I would do it, and I like to do it too. And then as I got older, I developed an interest in the math and sciences, if you didn't know, and that just opened up a whole new world of building for me. So I could build a bottle rocket in physical science, or make a new compound in chemistry, or an egg drop device in physics, and with the added concepts of math and science, I could actually understand how it was working or not working, and I thought that was really cool. So as I was thinking for a basis for my capstone, I remember Genesis and how God created Adam, and Adam was created to work the ground and work the earth. And in fact, Adam's name means earth. And even in the beginning, man was created to create, and I think that's still true today. And so for my capstone, I decided if Noah could build an entire boat without an instruction booklet or anything, and some guys in Egypt could build pyramids, or some guys in Rome could build the Parthenon, then I suppose I could try and teach junior hires about some Legos. So as I started off, I decided to have an interview, and I got a lot of good lessons from all of my experiences, whether it was an interview or an experience. I learned a lot, and I thought the best place to start would be with family. So I interviewed my uncle. He is a mechanical engineer. He got his degree from Purdue, and he now works with companies such as Boeing and Airbus, selling parts to them for airplanes. He likes to call himself a marketing engineer, which means he has like an engineering background, but he also sells things to companies that have to do with engineering. So he's knowledgeable about the parts. He may have learned about them or used them or even designed them himself. So he knows a lot about them, and he's able to sell them and tell them actually about them, and that's pretty cool. And his company really needs people like him that, like I said, know about the part and can effectively sell it to companies that need it, and communicate what the part does really well. So during that interview with him, I learned all of that before information through questions, and then I ran out of questions, and I asked him if he had anything else for me to say, and that was when the really good information started coming in, when I didn't constrain him to any certain questions or topics. And that was when he really started talking about what he loves, and I thought it was really interesting how once you just let someone talk about what they love, they can really say a lot of good stuff and really go on for a while. So basically, he gave me two really important things that you need to be a good engineer. Number one, you just need to be not afraid of high-level math. And then number two, and more importantly, you need lots of engineering labs and engineering experience, either before you graduate or in your first year of college. And that will really help you in the long run. So my uncle, he had those labs, and he very soon figured out that he wasn't very good at electrical engineering. He was more mechanical, and he actually liked to see what was going on. So with like electrical engineering, you can't see the electricity going through the wires or powering anything or batteries doing stuff. But with mechanical engineering, you can actually see the parts moving and the parts interacting, and how that creates the entire whole machine. And I think I'm very similar in that I like the more physical aspects of engineering. But don't get me wrong, electrical engineering is really cool and technology is really cool. I've been on the tech team for 6 years, so I don't hate electrical engineering, but I think I'm more interested in mechanical, and that's what I would like to do for a job. And then one other lesson he told me is that the electrical, or just the engineering field, is very, very versatile, and you can do a whole lot with even just one degree, which is really reassuring, especially even just like before when Sierra and Nicole were talking about how they wanted the perfect job. That gave me a lot of comfort in knowing that I didn't have to choose the perfect job, because you can choose like anything, because you can do so much with one degree. Like my uncle, he went from like designing hydraulics for tractors to like inspecting airplane engines and whatnot. So that was really reassuring, how I didn't have to worry about getting the one perfect job. and there was always something new that I could do if I really wanted to. So even over the past year, I've seen during my experiences stuff that I might like to do, and I'm like, oh, that's interesting. And then, you know, a week later, I might find something else. So it's just, as an indecisive person, it's really good to know that I can do something new if I really wanted to. So like a dream job for me would be working for Lego, which is, you know, why I have these two things here. They're really interesting to me. And speaking of Lego, I decided to host a J-term on what I love most, engineering and Legos. So yeah, as my capstone is more hands-on, I decided it would be a good idea to host a J-term on that. It was for 9th through 12th graders. It was focused on building and programming and optimizing, you know, robots made out of Legos, and using the software to program them to do special things and whatnot. I don't think those are in here. But the school has these Lego EV3 kits, which is actually what that is. It's got like a ton of those. So I borrowed one of them during December so I could learn about it and, you know, be prepared to host my J-term. And it seems like you probably couldn't learn a lot from just a box of Lego parts, but I actually did learn quite a bit about it. When I was planning the course, it was definitely not as easy as I thought it would be, especially when then at the time I did not know how to program them. So the night I was trying to learn, I was looking through all the boxes trying to find instructions, and even online how to program them. Like, I don't know how to do this, and it's going to be a problem if I don't know how to do it during January. So after searching to no avail for instructions, I decided it was just best to take everything out and see what I could do. And before I knew it, you know, I was finding the software, which was actually already incorporated into the robots, like that one, and I was programming it myself, and, you know, building everything, which was much easier than I thought. It was probably pretty foolish of me to go straight to the internet instead of just assessing what I had. And I probably, if I had just taken it out and got it over with, I probably would not have learned as much as I actually did, because it was a pretty humbling lesson for me when I learned that, you know, the internet does not have all the answers, which is very true. When I was a kid, well, and still now, but I would ask my parents for help, and they would always ask me if I tried doing it myself or if I looked for instructions or, you know, tried figuring it out myself. And I really wish I had remembered that when I was doing that in December, because that would have made things a lot easier. And actually, you know, a decent amount of problems in the engineering field are probably a lot harder than they should be. We just make them hard on ourselves by making things more complicated, which I actually do that a lot. And I think I just needed a more relaxed approach. I needed to just start taking everything out and building and doing what I love. And that's what I did, and it turned out really well. Also, teaching a course is definitely just as hard as planning a course, which comes with several challenges. You know, getting everybody to engage with the material and pay attention, because I do believe that everybody can be an engineer in their own special way, and it was just up to me to help them, you know, use that part of the brain that they might not use very often. But once I did, I could not have been happier with the result, because everybody, you know, was building their own things, special designs, special skills that were all doing their own cool thing, and it was really great to see people doing that. Actually, during the J-term, I planned a race where you had to modify your robot using gear ratios and wheel sizes, because the motors only turned one speed. So I was challenging them to see if they could figure out how to make it go faster without, you know, upping the motor speed. And it was really great to see engagement, partially because Probst bribed them with gift cards, but also, you know, it was really interesting to see how they thought of everything themselves and, you know, started engaging with the challenge and problem solving their way through it. So I think it was really interesting for me to see how the ideas from people's own brains, you know, came up with these really great creations. And I think creativity is really, really essential to engineering, you know, which might seem pretty intuitive, but with all the formulas and numbers and everything, there's a lot of use of the left brain, the more analytical side, and there's no use of creativity sometimes. So there's no colors or special designs, which I think is a really great part of engineering. And I also believe it's pretty much impossible to only use one side of your brain. In fact, the best ideas from mankind have come from both sides of the brain. Like the Wright brothers, they came up with this crazy idea that man could fly, and then they actually made it work, like more than 100 years ago in 1914, I think. The creative side, comes up with this idea that might seem crazy, and then the more analytical side, the left side of the brain, kind of cuts off some parts, but for the most part makes everything work, and makes that crazy idea actually a reality. When I was interviewing my uncle, he had this quote. It usually takes 1,000 mistakes before you invent something good, and that's pretty true, because it takes thousands of tiny corrections from that one crazy idea to make it an actual reality. Like in my J term, people had these crazy ideas, which I didn't even think would work, but then they modified it and optimized it to make it actually work. And there were a lot of failed ideas and prototypes that didn't work, but in the end, a really cool creation was made of a really nice robot that did cool things, like this little elephant over here. One kid, he made, actually two kids I think, they made, instead of using wheels, they used like tank treads, and they made it turn without like actual axles. That's the whole thing, is the result of the analysis side of the brain and then the creativity side of the brain combining to make a working idea. So that was all in the first semester, and then I moved on to the second semester, and I tried to keep those previous lessons in mind, but I also tried to have an open mind so that I could learn even more. So really the main thing I did in the second semester, I went with my dad on a business trip to Salt Lake City, to the VA hospital, Veteran Affairs in Salt Lake City. I toured a boiler plant that heated basically the whole campus, which was really cool. I went with an inspections team to make sure 2 MRI rooms were up to code and everything was good in the construction of those. And then I also interviewed a friend of my dad's who's a structural engineer with a partner company, Canyon Structural, and that's what I mainly want to focus on, because that was really the good part of my experience in the second semester. Her name, the person I interviewed, her name was Cambria Flowers. She's a structural engineer, like I said, and I really liked the interview because a lot related to my capstone and a lot of good stuff came out of it. The first question I asked her was, "What do you love about your job?" And then she appropriately responded, "I'm finding solutions to problems every day. That's what engineering is." And that is the most true thing I could have gotten out of that. So that was really cool. And then later in the interview, I got to see what she actually does and how she changes the world for the better with her engineering skills. So she told me one thing she loves is, since she's a structural engineer, she deals with buildings a lot and lots of big structures. She's actually able to go and see what she was a part in building, and even go inside of it, which was really cool. She told me this story. Her company interviewed a woman who left her previous company because she was looking for a company that had more sustainable ideas and better sustainability practices. And Canyons was really good at that. They have these projects where they use all recycled material. So speaking of sustainability, wood is really expensive right now, from wildfires and deforestation, and also Canada just not wanting to give us stuff. So she said, if you have a bunch of wood shavings and some industrial glue, what would you do? And I can tell you what Canyons did. They glued the shavings together and they made plywood, and they used that for construction. And it might not be the best looking thing to build with, but it works and it's sustainable because it used all recycled materials, so no extra wood is needed. and if you treat it right, it can be stronger than a 2x12, and it's really, really good for building actually. They also use straw to make, like straw bales to make structures in Moab, Utah. And then along with wood, steel is also really expensive right now. So if there are, you know, all these shipping containers just rotting in landfills all over, I mean, you can do so many good things with that, like Canyons did. They do a lot of shipping containers construction where they use those to make sustainable houses, you know, where they don't have the best materials to build with. And that those shipping containers are made of tremendous steel that is really, really strong actually. So, you know, why not use it for housing? And actually, my grandparents have a cottage out in Indiana off a lake. You know, 2 of the rooms are made of shipping containers and they're fully furnished and everything. And, you know, that just goes to show how sustainable, you know, shipping container construction can be. And that was just a really good example of sustainability that I hadn't really thought of before. And I would really agree with it. Because, you know, recycled material is good to build with, and then we don't use up more material. And if we have humans keep using materials to build with, then, you know, what am I supposed to use? So over the year, I learned a lot about engineering and problem solving. One thing that I learned from my uncle that I really liked was I shouldn't just sit around, and I should actually start doing things, because mistakes are okay. And he said that it's better to make a bad decision and learn from it than to sit there frozen and do nothing, because then no learning happens, which, you know, is very true. And even if you make mistakes, you know, those are good too. I think mistakes can even count as accomplishments because they lead to even better accomplishments and advancements. He also said, a lot of learning has happened in the world of technology by mistake, and that's also really true. I think both of these quotes are really integral to engineering as a whole, because, you know, like my uncle said, most of the mistakes in engineering have led to better things, and those better things have led to, you know, the world we have now. So, like, for example, how Canyons uses recycled material to make structurally sound and sustainable housing, and I think that's really cool. So I'm striving to, you know, follow that advice that I've been giving from many people. And you know, like I said in the beginning, Genesis was really impactful to me, because God made man to create, and man was created to create more. And thankfully, God also gave us the skill of problem solving, and that's, you know, really great to have, especially if you're building a lot of cool things. So by combining these God-given gifts and the desire to create, as well as the capacity for abstract thought, we are able to portray God through and with our own creations. Thank you.